Hello students, welcome back to the class. Today we will see the NCERT Chapter 2 Structure of Atom CBSE Sample Paper Questions. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. The first thing that we will see is the design of the sample question paper. Second thing is the multiple select question. So there are two questions asked from this chapter. Now remember students that this quality and the quantity that I am describing here may vary from school to school. So this is just a standard one that I have taken directly from the NCERT. Next is short answer question. So 5 questions will be of this short answer type. Then in this design of the sample question paper, we will first talk about the blueprint. So from structure of atom, we are asked questions of 5 marks where there is a one MCQ having 2 marks and there is a short answer question which is having 3 marks. So what is the required time and the length of the answer that should be followed ideally? If I talk about the MCQ, then 2 minutes should be given for 1 marks type question, and for MCQ which are having 2 marks, they should be given 3 minutes. Then in short answer type, the 1 mark question should be given 3 minutes, the 2 marks question should be given 4 minutes, and the 3 marks question should be given 7 minutes. Next is the assertion reason type. It should again be given 3 minutes. And the long answer type is given 15 minutes. So remember student, this is just an ideal case. From it may vary from person to person, but still if you are trying to guess a number or a time that you should allot to your each question, then this can be a good starting point. Moving on to the difficulty level of question. So there is 18% easy questions in your paper, then 64% average questions, and 18% difficult questions. Here is your first question. It is an MSQ type. Therefore, multiple options can be correct. And mostly, I would say it is a 2 marks type. And in examination, you would be asked to select 2 options, right? So the question says that identify the pair which are of isotopes. Your time to solve this question starts now. The time is up. Again, I'm repeating it. You have to select 2 options always in MSQ type of the sample question paper. Okay. Now it may be written different for different schools. So the guideline must be mentioned there. But here, if you take a standard thing, then it should contain 2 types of MCQ. One should be of a type that will have 1 correct option, and second should be of a type that will have 2 correct options. So this is the second type. Now in this question, you have to identify the isotopes. What are isotopes? The elements which have the same number of proton, that is, the atomic number is same. Those are called as isotopes. There is one more relative term to this. I would say not relative, a similar term to this, which is isobar, that are given to the elements which have the same mass number. So if I talk about the isotopes, I have said you that they have the same element. They are the same element with same atomic number but different mass number. What is the reason behind it? So if you take the definition of mass number, it is equals to the number of protons plus number of neutrons. Since your number of protons is same, therefore the atomic number is same, but the number of neutron is different, therefore the mass number is different. So we have very large amount of isotopes that we know, starting from hydrogen, moving on to chlorine and so on. So the first isotope is in the first option. The first option is correct, and it has two compounds which have atomic number as 6. So there will be same number of proton in these two compounds, but they have a different mass number, 12 and 13. So they are isotopes. Moving on to the next one. So the second option is also true. Why it is true? Because it is also having the same atomic number. So this is, I guess, chlorine. Okay, so chlorine has the same type of isotope, but their mass number is different. 35 is for the one and 37 is for the other. Now again, their number of proton will be same, but their number of neutron will be different. As a result, they are isotopes. One very important point regarding isotope is that they have the same chemical property. There is a difference in the physical property, but the chemical property almost shows same relevancy for the two isotopes of the same element. Now, moving on to the incorrect options. So what are the incorrect options? The first is 3. The third is not a isotope. Instead, it is a isobar. It is a set of isobar. How? See here, you can see that they have different atomic number. So now it is very much known that they cannot be isotope as first. But since they have the same mass number, therefore they are isobars. I think you are getting the point. Okay. Now moving on to the next incorrect option, which is having again the same mass number as 8, but the atomic number is different, 4 and 5. So they are having the same number of what? Proton plus neutron, but different number of proton. So remember, students, that it is not concluded from the point that they are isobars. So if you are saying that they are isobar, you cannot say that their mass number is same. Their mass number is same, but their neutron number is same or their proton number is same. Okay. So if I am saying that they are isobars, only one thing is true, that their mass number is same, but their number of neutron and proton will vary. Okay. Remember this point. It is very important. So for isobars, they have neither the equal number of proton nor the equal number of neutron. Now, what is the final answer? If 1 and 2 are correct, then we can write the correct pair of isotopes is 1 and 2. Now you will get answer in MSQ only if you write both of the correct options, and plus you don't need to give this much explanation, only you need to write the final answer, and that will give away your 2 marks. Okay, you don't have to write this statement also, you have to write just this. So since I have written here 1 into 2, that will give you 2 marks. Moving on to the next question, you have to identify from the given sets of quantum number that which one will have the highest energy if electrons are filled in it. The first set is having n value as 3, L value as 2, okay, then ML value as +1, and your MS value as +half. Second is having n value as 4, L value as 2, ML value as -1, and MS value as +half. Third one, again same thing, n value as 4, L value as 0, ML value as 0, sorry, L value is 2, ML value is 0, and MS value is -half. The fourth option, N is equals to 3, L is equals to 2, and ML is equals to -1, and MS is equals to +half. Your time to solve this question starts now. So let us see. So this is a question from the NCERT section 2.6.1, which includes the filling up of electron and plus the energy determination of electron. Now, here, if you calculate the N plus L value, then N value will be 3, L value is 2. It is given. Okay, no issue in this. But what about the value of ML and MS? So remember, students, if you are determining the energy, you are not to worry about this ML and MS value. You have to only worry about the value of the principal quantum number and the value of azimuthal quantum number. You add them both. If they both are different, then the one with the higher energy, higher value will have the higher energy. If they both are equal, then go for the N. The one with the highest value of N will have the higher energy. So if you do this for the first set, you will get it as 5. Similarly, for the second set, principal quantum number is 4, azimuthal quantum number is 2, therefore that value of N plus L is 6. Third one, the value of principal quantum number and the azimuthal quantum number is again same for both of this. For the last one, the value of N is 3 and L is 2, therefore N plus L value is 5. Now, we can say that option 2 and 3 are correct. Why? Because both of this have the same N plus L value. Okay. Now, ML and MS value do have something to do with the energy, but that can be neglected. Okay. And as a result, second and third will have the same energy. Again, in this question also, you have to just write the correct answer and you will get your 2 marks. So we have done 2 MSQs which are having 2 options correct. Now we will move to the next type, which is short answer type question. So this is of 3 marks now. The question is from the NCERT section 2.6.1. An electron is in one of the 3D orbitals. Give the possible values of N, L, and M. Now you have to write the possible, each and every possible value for M. Okay. So this is basically what? This is your magnetic quantum number represented by M. Your time to solve this question starts now. Your time is up. How will solve it? I guess it's very simple. Just look at the subshell notation 3D. Okay. From here you will get half of your answer. So if it is 3D, then the possible quantum numbers are, first of all, for the principal quantum number, if you say, here you can look again, as I said that, at your subshell notation. It is 3D. Therefore, the value of N will be what? It will be 3. So this is 1 mark. Second is the azimuthal quantum number, which is the value of L. Now for a d orbital, you know it is, since they are 3D, so it is a d orbital. What will be the value of L? It will be 2. You remember it, right? So for N, for L is equals to 0, the orbital is S. For L is equals to 1, the orbital is 1. For P, okay. For L is equals to 2, the orbital is G. If you write this, you will again get 1 more mark. So 2 marks are already from this 2 quantum numbers. Now we are left with the third quantum number. So what would that be? So that would be the magnetic quantum number, which is again can be represented by ml or m both. So what are the possible values of ml? Now for this, you have to do a very short calculation, I guess. But for the two quantum numbers, which you will get 2 marks, you don't have to do anything. Just look at the subcell notation, you will get your answer. Now coming on to the possible values of ml. What was the formula for that? You start from the minus L and move to the plus L. So starting from the -2, we'll move to +2, which will give you 5 values. -2, -1, 0, +1 and +2. So this will give you away your remaining 1 marks, and that complete your 3 marks question. I guess it is clear to all of you. Now moving on to the next question, which is again a short answer type question. So there is an element whose mass number is given as 81. And it contains 31.7% more neutrons than the protons. Assign the atomic symbol. So this is asked from the NCERT section 2.2.3. Your time to solve this question starts now. The time is up. So what is the formula for the mass number? You must know that thing for sure. And it is given equals to 181. And second thing that is important is that it has 31.7% more neutrons as compared to protons. So you must know how to calculate the percentage. That is important here. If you know both of this, then we can proceed. So if you consider, suppose, the number of proton as x. Now, what is the number of neutron? It is 31.7% more than the proton. So you take 31.7% of x, that is 0.317 into x, plus your number of protons. So the number of proton plus the extra percentage. That will give you away your total number of neutron. Okay, so now we have the number of proton and the number of neutron. As I said, you should know the formula of mass number, which is number of proton plus number of neutron. This is given in your NCERT equation 2.4. You have already been given the value of 81. Now put all the values in the above equation. You will get x plus 1.317x is equals to 81. Now this is a one variable equation. So you have a variable and you have one equation. You can easily solve it. If you will solve it, you will get the value of x as 35 approximately. Now we will move on to the next thing, because now we have got the number of protons. So what are we need to calculate? We need to assign the atomic symbol. Okay. So if we know the number of proton, we know the atomic number and the mass number is already given. So we are ready to write the atomic symbol. But before that, I am giving you one more information that you can get from here. And that will be the number of neutron. How you will calculate it? I guess it's very simple. You have the total number of proton plus neutron and you have the number of protons. Subtract both of them. You will get the number of neutron as 46. So this is an additional information. Questions can be asked from here also. So I have done it for you. So if you know the atomic number, you are getting the 1 mark here. Okay, you are getting the 1 mark here, because it is equals to the number of proton. We have written it as 35. Now, which is the element that is having atomic number of 35? It will be bromine. Okay. Then we can write the atomic symbol. 81 as the mass number, 35 as the atomic number, and Br is the element that we're talking about. Now, one more important thing. You can write it X instead of this Br. No worry in that. Here it is only asked to write the atomic symbol. You are not asked to determine that which element it is in specific. If you write X 8135, that will also give you 2 marks. So I have just written information that this element is nothing but your bromine. I guess it is clear to all of you. Moving on to the next short answer type question. You have to know that what is the number of photons of light that are having a wavelength of 4000 picometer that provide 1 joule of energy. Okay, your time to solve this question starts now. The time is up. So first, let us try to understand the question. Question is saying that you have a light, okay, and that light is having a wavelength of 4000 picometer. Now you have to determine that how much photon you will take of this wavelength, given wavelength, that the total energy become equals to 1 joule. So this is from the NCERT section 2.3.1. How we'll do it? For that, first we will write the given data. Wavelength is given 4000 picometer, therefore it will be 4000 into 10 to the power minus 12 meter, or 4 into 10 to the power minus 9 meter. Second thing, the total energy is given as 1 joule. If you write the given data, you will get half marks from here. Next is the energy of 1 photon. How do we calculate it? It's very simple. You know that every light travels with the same speed, that is c. So you don't have to worry about c. The value of Planck's constant is also not variable one. So you have to calculate the energy, and lambda is also given. So what are these three things? Once again, h is the Planck's constant, 6.626 into 10 to the power minus 34 joule second. It is at value. C is the speed of light in vacuum, which is 3 into 10 to the power 8 meter per second. And lambda we have converted into meter as 4 into 10 to the power minus 9 meter. Now let us substitute all of these values in the first equation that we have seen. If you put the values also, you will get your half marks. Now moving on further, what we will do now? We will calculate the final value for the number of photons. So if the total energy is given as 1 joule and 1 photon has an energy of a value which is already calculated in the previous deck, okay, if you know these two things, you can calculate the number of photons. It is again a simple application of what? Of the unitary method. Okay, so if 1 photon has this much energy, and then what is the number of photon which will have 1 joule energy? It will be E total by E photon. That is energy in total by energy of 1 photon. Put the values, you will get your answer as 2.01 into 10 to the power 16. So this is of again 2 marks. Now I'm leaving this calculation on to you. Just take all the values that we have seen in the previous slide, put it here, and take the total energy as 1 joule. You will get your correct answer. I guess it is clear to all of you. Now moving on to the next question. Here we have to calculate how much energy is required to ionize a hydrogen atom if the electron occupies n is equals to 5 orbit. Compare your answer with the ionization enthalpy of the hydrogen atom, where the energy required to remove the electron is from the n is equals to 1 orbit. So this is a difficult question. So you will put this in the reason of the difficult one. Previous one was of a average type, okay, and the first two was of the easy type. So this is from the NCERT section 2.2.3. Your time to solve this question starts now. Your time is up. Let us see how we can solve it. The question is saying that you have to ionize a hydrogen atom, and your electron is already present in the excited state, which is n is equals to 5. So to ionize something is to remove electron. That is, you have to put your electron where n is infinite. Okay, just putting out of the atom means in a way that you are putting it in an infinite distance with respect to the nucleus. Now you have to do this calculation, and also you have to do a calculation where your electron is present in the ground state, and you have to move it again in the infinite space. Now, after doing both of this calculation, you have to compare that which one is requiring a lesser energy and which one is requiring a larger energy. This is from the NCERT section 2.2.3. How we can solve it? First of all, you have to look for the ionization energy starting the electron from n is equals to 5. So again, our task is to move the electron from n is equals to 5 to n is equals to infinity. Now here an important point to remember. We have already discussed this part that at infinite distance the energy becomes maximum, that is 0. How do we know it? Because energy is directly proportional to 1 by n square. If you take the value of n as infinity, that 1 by infinity square will give you 1 by infinity, and that is equals to 0. Therefore, energy at the infinite distance will be equals to 0. Now, what is the energy difference between n is equals to 5 and n is equals to infinite? So for that, we will put the values. Infinite distance, at infinite distance, the energy is 0. For n is equals to 5, we put the formula minus 2.18 into 10 to the power minus 18 z square by n square. Now for hydrogen atom, z is 1 and n is 5. So 1 square will give you 1. So I have not put up that value. 5 square is written here. That energy comes out to be 8.72 into 10 to the power minus 20 joule. Now this is of 1 marks if you do this part. What is our next part? It is to be calculated the energy that is required to remove an electron from n is equals to 1 to n is equals to infinite now. So your electron is present at a lower state. And what is that lower state? Of course, it is your ground state where n is equals to 1. So for n is equals to 1, the energy can be directly written as 2.18 into 10 to the power minus 18. So we have already calculated it in the theory part. I'm writing it directly here. So this is again of 1 mark. You can calculate it also if you want. You use that same methodology that you have used previously. Take infinite energy as 0. Take the ground state energy. Take 1 square instead of 5 square. You will get this thing simply with a positive sign, student. Remember, you have to apply electron. You have to apply energy to remove the electron. Okay, so this is important to note here. Now on doing the comparison, what we can say, for n is equals to 5, the energy was 8.72 into 10 to the power minus 20 joule. For n is equals to 1, the energy is 2.18 into 10 to the power minus 18 joule. Therefore, it is very clear from this discussion that n is equals to 5 requires a lesser amount of energy as compared to n is equals to 1. So this is very simple because n is equals to 5 is already in a higher excited state, whereas n is equals to 1 electron is in a ground state. So it will require more energy as it is more stabilized because of the least distance that is possible between the nucleus and the electron. Now this is your last question. You have to calculate the de Broglie wavelength of an electron which is moving with a speed that is 1% of the speed of light. This was asked. This is from the NCERT section 2.5.1. Your time to solve this question starts now. The time is up. Let us see how can we solve it. The thing that is unique about this question is that in this question you have to take the speed of light lesser than the actual one because this is mentioned in the question. So this is just a hypothetical case. Okay. And since we are talking about the electron, we don't have to worry about the exact speed of light. Okay, because electron do not move with the speed of light. And it is taken a case where it is moving with a speed that is 1% of the speed of light. I guess it is clear. Now, if the given data is clear, then what we can write? That the speed of the electron can be written as 0.01 into c. So 1% of speed of light. So 1 by 100 will be 0.01 or 10 to the power minus 2 of speed of light, that is multiplied by the speed of light, which is c. Now what is the speed of light? It is 3 into 10 to the power 8 meter per second. But what are the things that we require for the de Broglie wavelength? It is mass, velocity, and the Planck's constant. So the Planck's constant value we know. The mass of electron is 9.1 into 10 to the power minus 31 kg. And Planck's constant is 6.626 into 10 to the power minus 34 joule second. Now let us try to calculate the speed. So if it is written as 0.01 of this, we can write it as 3 into 10 to the power 6. Very easy. Just remove this decimal and you will get 10 to the power 8 converted to 10 to the power 6 if you divide by 10 to the power 2. Now we know the speed of the light, we know the mass, we know the Planck's constant. Now we can calculate the de Broglie wavelength. For that, what you should know? You should know the equation that is required to calculate the wavelength, which is lambda by hmv. If you write this formula also, you will get 1 mark. And if you calculate the speed, you will get 1 mark there also. This is the NCERT equation 2.22. Next is to plug all this value in the given equation. So h is put here. This is the weight, or the not the weight, the mass of electron. It is the speed, which will give you 2.43 into 10 to the power minus 10 meter. So if you do this, you will get a 1 mark. Okay, so write it stepwise as I am detailing you. So this was all for today's class. Thank you for attending the lecture.